So the area is calculated by taking the integral from a to t of x dx. And this is y equals x. That's the original function. And so that area, of course, is the shaded area under the graph. So t plus a divided by 2 multiplied by t minus a is the formula for the area of a trapezium, or a trapezoid. So the two parallel sides, we're going to add them together, divide by 2, and multiply by the height between the two. Okay, so what we can do is we can now expand this out to write it in this form, f of t minus f of a. So if we look at that, we can say a of t is, I'll just rewrite this, t minus a over 2 multiplied by t minus a, sorry, t plus a over 2. And I'm going to bring this 1/2 out front, and then we're just left with t plus a multiplied by t minus a. And then when we expand this out, we get t squared minus a squared. And I can just multiply this 1/2 in now, so we get 1/2 t squared minus 1/2 a squared. So a of t, being written as uppercase f of t minus uppercase f of a, is actually 1/2 t squared minus 1/2 a squared. And a is just a constant that we had discovered, or we had set x to be equal before. So f of x then is 1/2 x squared plus c. We'll just, because that's a constant, we're going to let negative 1/2 a squared be c. Okay, so that's our uppercase f of x, which is the integral, or the antiderivative, of f of x equals x. Okay, so if we were to take the derivative of this, uppercase f of x prime will give us, well, 2 multiplied by 1/2 x. The plus c becomes 0, so we're just left with x. Sorry, not the squared, just the x. And that, of course, is our original function, f of x. Okay, so what I'd like you to do is I'd like you to go through the last two parts of that investigation on page 450. That would be parts number 3 and 4. In part 3, we're given the original function f of x equals 2x plus 3, which you'll see in the textbook is another trapezium, and it shows you the first step, but then I'd like you to continue with that. And then in part 4, part A, we've got 1/2 x plus 3, and part B, we've got f of x equals 5 minus 2x. Okay, so I'd like you to go through the same process with 3, 4, A and B, like we did with parts 1 and 2. And then for number 5, part 5, we've got this original function f of x equals 3x squared plus 4x plus 5. I'd like you to predict what the uppercase f of x is going to be and what the area will be between values a and t, without going through all this algebraic procedure that we've done earlier. Okay, so try to do that just by using intuition now. So now that you've gone through the investigation, that's basically the first principles method of finding antiderivatives. So as I mentioned before, when you go through the first principles technique of finding the derivative, we see that that's the limit of f of x plus h minus f of x all over x plus h minus x as h approaches 0. That's the first principles technique of finding the derivative. When we use first principles to find the antiderivative, we're basically using the area under the curve. So for functions that are positive, so they're above the x-axis, if we're evaluating the area under the curve between a and t, we see that that's actually equal to uppercase f of t minus uppercase f of a, where f prime of x, uppercase f prime of x is actually equal to f of x. And of course, uppercase f of x is the antiderivative of f of x. Okay, so this now becomes, or what is known to be as the fundamental theorem of calculus. So for some continuous function f of x with the antiderivative uppercase f of x, when we find we're trying to find the area under the curve, that is simply the antiderivative evaluated at the second endpoint minus the antiderivative evaluated at the first point. Okay, so that is the big thing that we're going to be using. So we're going to be looking at a couple examples tomorrow, and then I'll give you a chance to work through the practice questions in class. I would like you to take a look at some of the examples in sections 18b and 18c. Click on the self-tutor to allow her to explain things to you, and then I'd like you to just take a quick perusal of questions 1 to 3 on page 499, and then on page 453 to 454 just take a look at numbers 1 to 5, and these are the ones we're going to be doing in class tomorrow after we look at the couple examples that we have for you. Okay, so thanks for watching, and we'll see you in class.